Welcome to 8.2 Arcs and Chords. First, let's start with a central angle. A central angle is an angle whose vertex is the center of the circle. So here, our vertex is the center, and it opens up to the parts or the sides of the circle. And our angle is just the measure in between. Now onto arcs. We got a minor arc is just a part of a circle that's less than 180. A major arc is between 180 and 360. And a semicircle is exactly 180. It's the endpoints of a diameter. Major arcs and semicircles are named with 3 points. A minor arc is going to be named with 2 points. So let's look at this circle here and let's name some arcs. So we have a minor arc in here. This is AB. From A to B along the green part of the circle, that is what we're talking about, not the length straight from A to B. Right? It's the arc from A to B. So a major arc in this picture could be ABD, starting at A, going to B, going all the way around to D. Right? Again, you're following the arc of the circle. And a semicircle could be BAD, from B to A to D, gives us half of a circle. Alright, the measure of a minor arc is just the same as the central angle. So if the angle is 50 degrees, then the arc is 50 degrees. The measure of a major arc is 360 minus the minor arc. So again, if the minor arc was 50 degrees, then the major arc would be 310 degrees. It's the measure from the point to the other point going the longer way around the circle. To add this to our theorem page, the arc addition postulate, the idea is that you can add two arcs together. So here, the major arc ABC equals the measure of the minor arc AB plus the minor arc BC. Another definition, we have congruent arcs. It's just two arcs that have of the same circle, or of congruent circles that have the same measurement. So what congruent means, same measure. So arcs and chords theorem. The idea here is in the same circle, if you have two congruent chords, then you have two congruent arcs. So here AB is congruent to BC if the line segment AB is congruent to line segment BC. Add another theorem in there, perpendicular diameter theorem. The idea is if the diameter is perpendicular to a chord, then the diameter bisects the chord and its arc. So here DE is congruent to EF, and arc DG is congruent to arc FG. To go backwards, if they're congruent and it's perpendicular, then it is a diameter. So here JK is the diameter of the circle. Another theorem, congruent chords theorem. Here in the same circle, or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So in this one, AB is congruent to CD if and only if EF is congruent to EG. We also need the perpendicular in there because equidistant, you always want to travel the shortest distance. Okay? So let's look at some examples in this. LM is the same as the central angle 70 degrees, so LM is just 70. M to N to L is everything except for the 70 degrees. So we're going to take that away from 360. 360 minus 70 is 290. LMN, that is along a diameter, so that's a semicircle, so that's 180. Alright, example 2, find the measure of the red arcs. Are the arcs congruent? Well, the central angle for AC is 41 degrees, so AC is 41 degrees. And it's the same for DE. So since they're both 41 degrees, since the arcs are in the same circle, and they are congruent. Here, find the measures of the red arcs. Are the arcs congruent? Well, the central angle is 81 for both of the arcs, so they're both 81 degrees. But since they're not the same circle or even congruent circles, they are not congruent. Okay. But their measures are the same. Example 4 here, we have congruent chords, so we know the arcs are congruent, so we can set those equal. 3x plus 11 equals 2x plus 48. Subtract 2x, we get 1x. Subtract 11, we get 37. To find out how big the measure of arc BC is, we're going to substitute 37 into 2x plus 48, and we get 122 degrees. So that's it for the notes. Good luck on the practice.